Hey guys, Mr. Backerwick here. In this video, we're going to look at solving some trig application problems. Now in this first example, let's say we're looking at measuring the height of a tree. So there's the ground, and here's our tree growing up out of the ground. And we've got the sun over here. Now the sun's rays are coming down, and that causes this tree to cast a shadow on the ground. And let's say we know that the shadow is 15 feet long. And let's say we use an angle measuring device to measure this angle inside of here to be a 65-degree angle. We're going to use that set of information to help us figure out how tall our tree is. So what we've just created in here was a right triangle. And we're going to do something called indirect measurement using this information to help us figure out how tall that tree is. We want to figure out this vertical height, so I'm going to call that x. Now we were given this 65-degree angle, so that's the angle that we're going to use. The x is opposite of that 65-degree angle, and the 15 is adjacent to that 65-degree angle. So opposite and adjacent means that we should be setting up a tangent equation. So we're going to go with the tangent of 65 degrees equals the opposite side, x, divided by the adjacent side, 15. Now our goal is to solve to get x alone. So to get rid of that divided by 15, I'm going to have to multiply that 15 over to the left-hand side. So we're going to get x equals 15 times the tangent of 65 degrees. Now we should be able to type all of this into our calculator. We do have to remember that since we're dealing with degree angles, we need to make sure that our calculator is in degree mode. So when we take 15 times that tangent of 65, we should get about 32.17 feet as our answer. So this tree is just a little bit more than 32 feet tall. So in this example, let's say we have an airplane taking off on a runway. So here's the runway, and I'm not going to try to draw an airplane, but let's say this dot represents my airplane. Now let's say we're standing over here on the runway, and we measure the angle of elevation up to the airplane. So what that means is from the horizontal, the angle that takes us up to where the airplane is located, that's our angle of elevation. Let's say we measure that to be a 15-degree angle. And let's say we want to find the ground distance that the airplane has covered when it reaches an altitude or a height of 1,000 feet. Since we're trying to find this ground distance, I'm going to call that my x. Now from this 15-degree angle, the 1,000 is opposite and the x is adjacent. So we're going to write out a tangent equation. So this would say tangent of 15 degrees equals the opposite side, which is 1,000, divided by the adjacent side, which is x. Now as we're looking at this fraction on the right-hand side, we're dividing by the x right now. So in order to get rid of that, I'm going to multiply both sides by x. But that doesn't solve our equation. That doesn't get our x alone. Right now our equation says x times that tangent of 15 degrees is equal to 1,000. So I need to get rid of this multiplication. So if I'm multiplying by the tangent of 15 degrees, in order to get rid of that, we're going to have to divide the tangent of 15 over to the right-hand side. So we're going to have x equals 1,000 divided by the tangent of 15. Now again, we have to be careful as we're typing this into our calculator. Since we're dealing with degree angles, we do need to make sure that our calculator is in degree mode. So when we take 1,000 divided by the tangent of 15 degrees, we should get about 3,732.05 feet. So that's the ground distance that our plane has traveled when it reaches that 1,000-foot altitude. Now we're going to do one more example in here. Let's say that we are standing on top of a 50-foot tower. So this tower right here, 50 feet tall. And let's say we're building a zip line. So we need a wire that goes from the top of the tower down to the ground. Now let's say we measure the angle of depression. So what that means is going horizontally out from the top of this tower, the angle of depression is the angle that's measured down from that horizontal. So let's say the angle of depression is a 10-degree angle. What I want to try to do is find the length of wire that we need along this zip line. So I'm going to complete this triangle out here. There's our right triangle this time. We said that the height of the tower was 50 feet. So since the tower is 50 feet tall, then this vertical side over here is also 50 feet tall. Now we're trying to find the length of the wires. That's the diagonal piece in here. So I'm going to call that my X. We're given this 10-degree angle, so that's the angle we're going to use to help us out. Based on what I'm seeing, the 50 over here is opposite of that 10-degree angle, and the X is the hypotenuse since it's across from the right angle in this right triangle. So based on dealing with the opposite and the hypotenuse, we're going to have to write out a sine equation. So we're going to do the sine of our 10-degree angle is equal to the opposite side 50 divided by the hypotenuse X. Now, since we're dividing by the X, what we're going to do is multiply that X over to the left-hand side. So now my equation says X times the sine of 10 degrees equals 50. To get X alone, I'm going to have to divide that sine of 10 over to the right-hand side. So now my equation says X equals 50 divided by the sine of 10 degrees. Since we're dealing with a degree angle, we will need to make sure that our calculator is in degree mode. Now when we take 50 divided by that sine of 10 degrees, we're going to end up getting about 287.94 feet. So that's the length of wire we need for this zip line. That's going to be it for this video. Thanks for watching.